Link test is going to be the first thing you're going to do. I don't care what you call me for, but if I log into your radio, I'm going to type link test. It's the first thing I'm going to do. I'm going to type link test. I don't care if you tell me it's linked. I want to see it for myself. I want to see what the RSSI is. I want to see what the MSE is. And link test is going to tell me everything. Okay? Remember, it only tells you about one side of the story, though. Okay? So you need to know the other side, too. Because I could be linked, but I can't get to the other radio. It could be because I'm not transmitting. My op mode is off. So you really need to check what the other side is. One tidbit, if you have ACM enabled on both sides, you would see your local side QPSK when the MSE is good enough for QAM 256. That would be an indication that the other side's not receiving anything. Okay? ACM happens independently both ways. So I could be running QAM 16 this way while I'm running QAM 64 that way. Okay? But it would be very unlikely or completely impractical to see an MSE of 36 and be receiving at QPSK, because that MSE should support QAM 256. So the only reason I'd be running QPSK is if I did not have a link the other way. Because if they aren't communicating, they just go down to the most robust modulation to try to communicate. Okay? Link test is the first thing you go to. Need a little bit more information, because link test shows you something's wrong. If link test looks good, then, you know, why bother at that point? Status modem might fill you in a little bit more on what's there, but not really a whole lot. I mean, I couldn't tell you last time I had status modem. Not a whole lot more than what's here. Okay. Status port, if you're having some kind of an Ethernet port issue, status port's what you're going to turn to. Something where you're not getting the throughput you're looking for. Let's look at status port. Remember, let's send that million packets across to see where they're getting lost. If I have a million in, but only 800,000 RF out, I know I'm losing them in that switch. It's probably because I'm bursting too fast. Right? Status PLL, this monitors the phase log loop channels between the ODU and the IDU. Long story short, they should all be locked. They should all be ones. If you do status PLL and you see 0, you have a problem.
That'd be a cabling problem?
That's what I'm going to tell you. Now, if you see status PLL is, one of them is unlocked, like your ODU TX PLL is unlocked, 9 times out of 10 that ODU's failed, and you're going to have to replace it. What I would do is I'd probably try cycling the power on the ODU power off, ODU power on, reboot. It might bring it back, but it might only bring it back for an hour and it's going to die again. If everything's unlocked, then you know that certainly could be a cable issue because they're not communicating at all. I would check the model, make sure the model shows. You can always try something. If you want to check to see if the ODU is working at all, try resetting the speed. Try resetting the frequency, because it'll fail, even though you know it's valid, if it can't talk to the ODU. Typically what you would see when there's an issue with a PLL is one of them will be unlocked and everything else will be locked. Okay? If they're all unlocked, then that's oddly suspicious. Something else is going on. If you're doing T1, E1s or STM1 or any of that junk, it's going to be status TDM, okay, instead of status port. On the Straddling 24, the CLI command is stats show, not status port.
That's only for that one command, or?
Yeah, all the other commands are the same, but for whatever reason, status port became stats show on the Straddling 24. SIG level will be the next point we would turn to if you think you're having an issue. Okay, and we're going to talk about what all these mean in a second. But it's going to give you some very critical information that's only used for diagnosing a problem. Okay, it's a lot of detailed signal information. First up's the IDU RSSI. This is going to show you what the RSSI is coming into the IDU or the OMU. different than the RSSI that you're seeing. I'll tell you what should be inside. Normalized radial MSE, it's just a little bit more detailed than the first MSE you see. Decoder stress, carrier offset power sensors, we'll talk about all of them in just a second. Alright, remember we had a very similar slide not all that long ago that talked about MSE. Actually, it was in the last hour. And I said that you needed to have 32 for normal. And I told you, I'm going to change those numbers. Okay? 32 is easy to remember, all across the board, 32. Well, I'm changing the requirements on you. Okay? For normal link running Qualm 256, your MSE should be 34 or better under normal. Okay? If your RSSI is negative 40 and your MSE is negative 30, you've got a problem. Okay? It might be that you haven't aligned the link yet. It might be that you have a cable issue. We'll talk about what all bad MSE means in a minute. Okay, again, my maximum expected when I'm doing the IF loopback would be 36. And my absolute maximum to maintain my BER at 10 to the minus 6, okay, it's going to be down there. I already showed you the loopback auto this morning that showed you the loopback IF and the loopback DIG. We've got it written down here. Okay, loopback IF should be negative 36 regardless of the speed setting or better. Okay, 38's better. Okay, if the loopback IF is fine, it's a negative 36 or negative 38. You don't need to worry about testing loopback DIG. If you use loopback auto, it's going to do it for you anyways because we just want to do it all. But if you test this and loopback IF is not coming in at 36, say it's coming in at 28. Now we know we've got an issue. We're going to narrow down where the issue is. So one, loopback DIG would be the next thing to check. Is digital okay? If digital is okay and it's 42 or better, then, okay, we know the IDU is working up until the point where it converts the digital signal back into an analog IF.
And that's only in command line, right? I don't see that in the GUI.
No, you can do it in the GUI too.
The GUI looks as loopback auto. It's the only one I'm seeing.
Yeah, the way you would do it, if you wanted to do it, there really is no reason to do this other than using loopback auto, in my personal opinion, anymore. But you could set the GUI. You can go to diagnostics, and at the top there's a loopback option. You can set it to loopback IF or loopback DIG. And then it will be hard set into that mode. Okay? But use the loopback auto. It's safer.
DG, okay.
It's going to do what you need to do. It's going to make sure everything's followed properly. Okay? There's an article on the support site. You just search for loopback that will walk you through this. I have a video that will walk you through this and talk about what these need to be. Because it doesn't matter what I tell you today, you're going to forget it. Okay?
Got a lot of confidence in this, huh?
I know, I did. Well, if I was sitting here for 16 hours listening to me, right after eating all that food, I'd be like,
It's Friday at 2 o'clock.
so,
For beers.
yeah. I mean, I'm assuming you're like me and would be not okay. So make a little note, CFAQ or C portal, whatever. That'll walk you through this. But here's the long story short. If this is negative 28 on the loopback IF, but the DIG is fine, I mean negative 42, better. We need to narrow down, is there a problem with the ODU? Even though we turn the ODU power off, are we still seeing signal in? Okay. If you had an incredibly hot signal, it could potentially still come through even with the ODU power off. I know you're all looking at me like, what? If it was really, really hot, it still could. Okay. Second, if you had a cable issue, when we do this loopback IF, that cable's still plugged into the front of this unit, right? Or that unit, either one. That will show up. So the next thing to do would be to go on site, power it off, unplug that cable, and run the loopback IF then. Again, do the loopback auto, it's just to make your life easier. Okay. If with the cable disconnected, the loopback IF result is good, negative 36 or better, now we know the IDU is perfectly fine. There's nothing wrong with the indoor unit. Same thing exactly applies for the Apex Plus ODU, except you're probably not going to climb the tower and cut the weather stripping off to disconnect the end connector. You probably send the whole thing back. Okay. If you unplug that and it's fine, the IDU is okay, 90% chance you've got a cable issue. Okay. Depending on how hard it is to get to the ODU, I might say go get the ODU, use a different cable, plug it in here, check the loopback IF with the ODU connected, with the ODU inside on a different cable C. If it's easy to run a new cable temporarily up beside the tower, or around the shelter, whatever, great, do that, see if it's better. Okay. Cable issues will show up as bad MSE. And a lot of times, it will, if they're bad enough, they'll show up as bad MSE in the loopback IF. Okay. Bad MSE, lots of times, is cable. Any questions on loopback and MSE? All right, this table right here. Okay, maximum threshold. Da da da. Okay. All I did was turn it around. It's the same numbers. Okay. I made it. I turned it around so it lines up with this. Remember this? You've seen this before. It's on page 3 of your data sheet. Here's receive sensitivity. Here's the absolute maximum MSE for 1e to the minus 6 VER. Where do you think the receive sensitivity comes from? 10 to the minus 6 VER. So, if everything's working right, if my RSSI is negative 65, and I'm on this 80 meg channel, okay, my MSE should be 28. For every dB above 65.8, I should see a dB improvement in my MSE. If my RSSI is negative 60, I would expect to see my MSE be 33. Now, obviously, once you get to about 36, it stops improving because you've just gotten to the point of no return. Okay. This is typically most useful for me with our old Giga and Apex. Quite honestly, they had a thing where after a firmware upgrade, sometimes they would lose their RSSI calibration, and I could check to see if their RSSI was calibrated this way. Today, what I typically use it for is when you guys call me up and tell me that something's not working right, and I look at you kind of sideways and say, well, is your link aligned? I say, yeah, it's aligned. And then I lower your transmit power, and I get it really close to 65. And when the MSE should be 28 at negative 65, the MSE ends up being like 16. I go, you're not aligned right. Okay? I can tell by doing this test. Okay? If you're not aligned right, the MSE will not be what it should be at the given RSSI. Note, you don't actually have to be set to this speed or this, or I mean, you have to be set to this bandwidth, but not this modulation to use this correlation. So you could be actually running QPSK on your link, and you could still check 65 to 28, which would still be the same. Okay. Useful for testing from time to time. Okay. Again, there's a data sheet. You can ask a question on a support forum that walks through the process of checking this thing. So before you call me and say, I don't remember what you said, you can go there and read it. Then if it doesn't, it's fine. Receiver maximum input. I said if you're getting above 30, you're getting into that area where it's not going to be so good. Well, there's a lot of it depends in my life. So it depends on what modulation you're running. Okay, if you're running Quantum 256, if your RSSI is as hot as 24, you're going to start killing the MSE. Okay? So that little rule of for every dB better than negative 65, there's a point of no return, and then there's a point at which it gets worse. That's the point at which it gets worse. Okay? If you were running QPSK, then you could go down to negative 14. DSK on a link that's got negative 14 RSSI. Again, my personal preference, if you've got more than about 40 dB of signal coming in, use ATPC to knock it down. And I'm not saying you got to do that if you're like at 8 or something, or 36. I definitely would rather you use ATPC